Have you ever wondered how computers read code? For us, code is a series of instructions written in a programming language that we understand, but for a computer, it's a different ballgame altogether. They need something more fundamental, something more binary. This is where the processor comes into play. Imagine a translator converting a complex novel from English to French. In the realm of computing, a compiler works somewhat similarly, translating high-level code like Python or Java into the low-level machine code that a computer's processor can decipher. This process is the bridge that allows computers to execute the tasks we set for them in the code. So how does this translation process work? It's not a one-step journey. It's a sequence of stages, each with its own responsibility. First up, picture a kid with a Lego set, separating each piece before starting to build. This stage is like that kid breaking the code down into individual tokens. These tokens are the basic building blocks of the code and can be keywords, identifiers, operators, or punctuation marks. Each token gets identified and categorized, ready for the next step. Next comes. This is when the compiler checks if all the Lego pieces have been put together correctly. It ensures that the sequence of tokens follow the rules of the programming language's grammar. It's akin to checking if each sentence in a novel is grammatically correct. Syntax errors are like misplaced or incorrect Lego pieces that the compiler can't understand. Then we have. Now, the compiler is not just checking for syntax, but also the meaning behind the code. It's like ensuring the sentences in a novel make sense and aren't just a random collection of grammatically correct words. The compiler checks for type compatibility, variable declarations, and the logical rules of the programming language. Once the code passes these checks, the compiler creates an. This is a version of the code that's closer to machine language, but not quite there yet. It's like translating the novel into simple French before converting it into complex, literary French. The intermediate code then undergoes. This is where the compiler tidies up the code, removing redundant instructions, reordering steps, and applying strategies to make the code faster and more memory efficient. Then comes the final transformation. The optimized intermediate code is transformed into machine code, the binary language that a computer's processor can directly execute. It's like the final French translation of the novel, ready for readers to enjoy. Finally, if the code includes multiple source files, the compiler performs a step. It combines the machine code from each file into a single executable file, much like compiling all the chapters of the translated novel into a single book. Once the compilation process is complete, the executable file can be run by the computer. The processor reads the machine code instructions one by one and carries out the operations. This process allows the computer to execute the program as per the instructions provided in the original human-written code. It's worth noting that compilers aren't the only way computers execute code. Interpreters are another method, translating and executing code directly without generating intermediate or machine code. However, compilers are more commonly used because they allow for static analysis of the code, helping to identify errors early on and generating more efficient machine code. So, the next time you run a program or an app, remember there's a whole process happening behind the scenes, transforming your high-level code into a language the computer understands. It's a complex journey, but one that's crucial for the magic of computing to happen.